So yeah, first of all, data science workflow. Just need some planning, and then we'll show the Wolfram way of a stable workflow. And then yeah, it has to be reproducible, because that will make data analysis easier for later use. And then the question, what is cooking? Data wrangling, import data, checking data, and data cleaning, and explore. We're going to look into the data from these 3 different aspects: cuisines, recipes, and ingredients. And analysis, it's just going in deeper. And with machine learning materials, like we will apply several different methods for machine learning. And then the last part, communicate. So we'll build a nice dashboard to present what we have found today. So yeah, first of all, data science workflow, we need to do some planning before we actually dive in. So in the perfect world, the expectation will be we obtain some data, and then we throw this data into a model to train the model, and then we can get some insight from it. However, in reality, it is not as simple as it looks like. So first of all, we can get some data from online, maybe from a database, from a website, and then we will need to do some data cleaning and data processing and data augmentation to make our data suitable for the task we would like to do. Just make them into pretty syntax and maybe manipulate the data a little bit more before we can put them into our model. And then, yeah, we need to separate the data into training test and validation sets. And then is the model selection, model training. Yeah, this involves a lot of like method choice, timing choice, things like that. And then after the model training, and then we use some test set to decide if it's a good model. And then it might turn out to be that it is not as good as we thought. That's when some fine-tuning comes in, and then that's the retraining of the model. It will go back and forth for some time, and then we want the cross-validation. And in the end, it will be results and visualization, and then we'll get our insights. So yeah, the Wolfram workflow. So here is just how we can help to build the whole workflow and to make it easier for you. So what do we have? We have a lot of interface and technique tools to help you clean the data, to visualize the data, and interactive notebooks. The one that I'm currently using, this one is called a notebook, and it's interactive. You can change and edit things here and there, and you can also just run your code live. That is easy for prototyping and the final product. And then natural language queries of data. We'll have an example later. And then instant visualization, machine learning. Yeah, machine learning in Wolfram language, it's very easy to use. It may be just 1 or 2 lines of code that can do a lot of things. And we also have a lot of building functions to support the automation of machine learning. And then neural network, easy to use. We have a neural network repository that there are some free pre-trained neural networks that you can use, and you can also modify them as needed. And the next one, it's going to the visualization and communicate part. Can generate a report, gathering all the information that we had, and put them in a nice visualization report. And then also, if needed, these can all be deployed in cloud, so your other people can have access to it easily. So yeah, how can this workflow help? So yeah, it's agile data science. Just tweaking and prototyping will be super easy, and it is reproducible. We can verify the result and build on existing result, and then put result together. So yeah, this also produce a workflow, established workflow for other people if they want to use it. So yeah, reproducible research checklist. So yeah, here we're just going through some steps of data science analysis. So yeah, at the beginning, it will always be data cleaning, data formatting. And then we need to plan out what we're going to do. And the second step is automate whenever possible. So yeah, instead of doing things manually, we'll probably want to write functions um, to process the data, to do the analysis automatically. And the third one, document your code. This is very important. Sometimes I write code that after a week, if I'm not writing comments, I might not be understanding what I'm doing. So yeah, just write down what your thoughts are when you're writing the code, and then it will be easier for you to maintain and easier for other people to read your code. For use version control. So yeah, as for now, most people use Git. So the good part of using version control is that you can do some experiment, and if that doesn't work, we can go back in time and then find the older version, the working version. And another good part of version control is that some people can just build up from your work. And yeah, and then it's all updated online, so that just in case there's anything happening to your own machine, you can always retrieve those from online. So yeah, very important step. Okay, the next one, record and preserve. Yes, we would like to keep the original version of the raw data, the sources, and also how are we processing the data, and the output, the cleaned data, the graphics. It's just easier for us to trace back what we have done, and doesn't so that we don't have replicated work. Yeah. And 6, prepare for obsolescence. Obsolescence. Yeah, things will change. The data you got from some online database, there might be changes to it. It might disappear, and some data are obtained from online sources that their web page structure might be changing, and then the same code might not work if you're using it half a year later. That's all need to be considered. And 7, prepare for portabilities. So yeah, as for now, like using version control, it's one way to prepare for portabilities, and then you can also upload it to some. As for us, you can upload it to Wolfram Cloud and make it public, so other people can have access to it. So yeah, these are just a brief checklist for what we need to consider before the data science process. All right, let's dig into our main example of today. Question: what is cooking? So yeah, here it's the question. So this website provided a data set for a competition on this website, and it's providing a JSON file of data that's including um, the ID of a cuisine, of a recipe, and what cuisine is this recipe, and then all the ingredients in this recipe. So yeah, the question is, when we have a list of ingredients, can we identify the cuisine? So now let's dig into the data. So yeah, the data has been downloaded to a local folder in additional files. So let's see what our directory is. So yeah, before this webinar, I have set up my directory to be looking into these additional files. This directory is just telling you, oh, which file I need, which folder do I need to find my files. So yeah, if not set up before, we can use this line of code to set our directory to this folder here. So this notebook directory is just the location of where this presenter notebook is, and it's in this building a data science pipeline folder, and then we're just telling it to look for the additional files here. So now let's look at the JSON file. So for our training data is just import this JSON file, and these are what we can import from the file. All right, let's do the import here. So yeah, as we can see, can I mm, all right, let's use this part. All right, great. So now we can see that this raw data is containing this ID and cuisine. It's Greek, and then containing all these ingredients. So yeah, that's our data structure at first, at the beginning when we just imported them. And Wolfram language has a pretty standard way to import JSON files. It can also import Excel files. So yeah, you have to look into the documentation of import to see what file we support. But yeah, we basically support all the mainstream data files. So yeah, now let's give a check of the data to have a basic understanding of how the data looks like. So first of all, we want to check the dimension of the data. So the dimension is it means that we have about 40,000 entries, and for each entries we have three different subcategories. It's like that. This is considered one entry, so that's about 40,000 recipes, and each recipe has this ID, cuisine, and ingredients have these three different aspects. All right. Yeah, it's just the same data structure. So now we can use to association from the general utilities packlet to structure the result into associations. So I would say for this part, first of all, for loading packlets, uh, this this is a shortcut for get this packlet. And to make it into associations. So association is a kind of data structure in Wolfram language that is very widely used in Wolfram language. It's just easier for some data processing later. So yeah, let's do that. And so yeah, for this two association function, it's not a building function. I think most of the time, because we have over 6,000, I would say almost 7,000 building functions in Wolfram language, it is sometimes the work is actually to find which function to use. So yeah, there's two association. It's actually not in our building function, but it is a pretty established and documented dark magic in this general utilities packlet. So that's where I want to introduce our notebook assistant. So yeah, this is our LLM support for finding things that you need help with. Can you tell me which function I can use to make my data set into associations? All right, let me do this again. Well, I meant to say hi, but oh well. Great. Or yeah, sometimes a lot of the work is to find the right function to use. So yeah, this one is just showing like if you're not familiar with association, like how can you make it into um associations. So yeah, it can also have help you to generate some basic ideas of how to start coding in Wolfram language. All right, great. So now we've make it into associations. So association is just like that. So yeah, still mostly the same. And now we're gonna find the number of ingredients in general, just pulling the third part out by using the key ingredients. So yeah, we have 400,000 something ingredients. That's like in total. It has not been cleaned, or like the duplicates are not removed. So that's like everything all together. And we can look into the length of all ingredients. That's this number. And the number of unique ingredients. That's where we use this function, delete duplicates, to remove all the duplicated ingredients from this 400,000 something ingredients. And now our unique ingredients has been lowered to 6,700-ish. Now let's see if the data types are appropriate and consistent. So for here, we are just looking into if the categories are consistent. And yeah, for every recipe, we have the ID to be integers and cuisine to be a string and ingredients to be a list of strings. So that's pretty consistent. That's good. And now we're going to find unusual string characters. It might means that the original data set have some interesting names in it, like a dash and percent, and these letters with accent, and this for the brand names, something like that. And this will be something we will consider to clean up later. All right, now let's look at this a histogram to see how how many ingredients are in a recipe, and number of ingredients in the recipe, like 10, looks like 10, 11, 9. So most of the recipes are in this area that have like 7 to maybe 12 ingredients in the recipe. And then we also have some very far away outliers, and we will also need to consider to clean this up later. And we can also check for each ingredient how long is the string length. So for maybe something like garlic, pepper, there are 6, 7 letters. That's fine. And yeah, it looks like there are here 6, 7-ish, and here 11, 12, 15. And yeah, most of the ingredients are less than 30 characters long. And then we might want to consider also clean up these outliers because they're just probably unique and maybe containing more information than needed. All right, so now let's look at duplicates. Yeah, for the cuisines, we want to look at where are they, what kind of cuisines they are. And for this southern US, it's it's southern US, and this Cajun here, it's otherwise known as French Louisiana. So let's see. For all our unique ingredients, 6,700-ish, and we're gonna look at these garlic powders. So yeah, when look into it a little bit deeper, a number of them are very similar. That garlic powder, garlic paste, garlic cloves. So in general, they are all garlic, and we would like to remove some of them because yeah, in general, they're just garlic. So now let's just do some cleaning of the data. So first of all, we want to drop the recipe data. We want to drop the ID because they're just numbers. They're not actually helping a lot with identifying which cuisine is from which ingredients. And then we're just using delete duplicates to just remove the duplicate recipes. And then now we can look into the sample of the data. We can use a dataset to present the structure of the recipes, or we can use tabular. Tabular is more used in rectangular data, and dataset is just good representation. So yeah, you can look into the documentation for this too. All right, now let's continue to do our cleaning. Because we looked into the cuisine, which has Southern US and Cajun, however, they are not from a specific country. And what we want to do is to replace southern US with the key Florida and Cajun with Louisiana. And it would be nice if we can convert the this location into what has been interpreted into say, yeah, that's our entity. So entity, this yellow little thing, entity is a collection of information that it's more than it looks like. It contains several different properties for this entity. Um, but yeah, as we can see, Florida is not a country, uh, and also Louisiana is not a country. So they have failed to be interpreted, and we're gonna do something about it. So let's just fix it together. We have this free form input that looks like this. And to enable this, I believe it's control and equation. So yeah, Florida, US. And then it is the administrative division. And when I accept it, it automatically changed into this entity version. So yeah, now let's just replace this Florida and Louisiana with the entity so that they look the same as all the others. All right. And yeah, now we're just gonna change, like replace all the plain text Greek into this country Greece. And yeah, again, Florida and Louisiana are not considered as a country. So yeah, the country names are recovered from the entities, but not the Florida and Louisiana. So yeah, as I said, entities contains more information than it looks like. So for this country entities, when we query for the properties, there are 762 different properties, and let's just show some of them, like television station, languages. Yeah, for the most common ones that are queried are like geo position, flags, population, GDPs, something like that. So yeah, that are all hand curated from reliable sources by us. So yeah, it's a great source for data. All right, now let's look into the ingredients. So yeah, the cleaning. So we want to see, besides the regular alphabet, what do we have in the characters here? And then we can see this percentage and yeah, accents. So now we're just looking into one of this percentage. This is 1% low-fat milk. So as for this case, we will need to keep everything that has the percentage. We don't want to throw it away, because if we throw it away, it's one low-fat milk. It doesn't make any sense. But yeah, we want to keep it as 1% low-fat milk. So now let's just clean up some of them. So yeah, this is like for brand name. This is for like maybe how much, or maybe some of the web processed characters. So yeah, this brand of classic olive oil. We can also use some other brands of olive oil, but yeah, in the end, they're just olive oils. So we're going to clean those up. And yeah, here we're just split the string like at this character and then throw away the first part and keep the second part. And then the second process is to use this string trim to remove white space here and there, and then to change everything into lowercase and remove duplicates. And as for now, after our cleaning, we have go down maybe like 50-ish ingredients. And can we reduce more? So yeah, first one is that we looked at the histogram and then saying that there were some outliers. Here we're just cleaning up all those that is greater than 30 characters. Oh no, 30 ingredients. Sorry. So yeah, for the recipe with more than 30 recipes, we'll just consider them as outliers. And also for this one, we're only keeping the ingredients that's less than 30 characters. All right. Yeah, and this moves us down from I remember we have 42 something, 4200 something. Now it moves us down by 2000. That's great. And here, what I put here is a comment, so that we would like to store the data at some point. Um, it is a good practice in real life because sometimes things just happen. You get a kernel crash, and maybe your code doesn't work at some point, or maybe you just um, did something more and want to revert. So yeah, keep everything in track and save them once in a while. It's a great practice. So here we saved it in the WXF file. It's I believe it's a binary file for Wolfram language, and there is also this .mx file that can use less storage. Um, but yeah, these two have different aspects. So for .mx file, it takes less storage space. However, it is not very transferable through different versions of Mathematica or Wolfram language. But yeah, this WXF file can keep us across versions. So yeah, if you know that you're only gonna deal with it in this particular version, my personal suggestion is to use the .mx file for better, quicker loading and save some space. So yeah, so now let's look at the number of unique ingredients. So yeah, just went down a little bit more. All right, now let's look at our near duplicate values. So yeah, as the garlic example, so garlic and garlic clove could be considered just as garlic. So let's look at that. So yeah, this one is to delete any ingredients that contains another. So yeah, so if garlic clove contains this garlic, then we remove the garlic clove. So yeah, this is our criteria. If the second one contains the first one, and then we remove it. And let's see how many. Oh, we actually went down quite a lot. So yeah, we went down from 6,000 something to like 1,600. And here it's another way to delete any overlaps with some characters. So this might overshoot. So yeah, like maybe tomato sauce is different than tomato, something like that. And yeah, we can see comparing to the first method, 1600, we've downgraded to 800. So that might be overkilling. So what we want to do is, yeah, um, yeah, what we want to do is probably go find the balance of how we want to clean this up. So yeah, in the first unique ingredients, this is what have left: tomatoes, tomato jam, large tomato, paste tomato. So yeah, paste tomato and tomato paste are the same thing, right? But yeah, this has some duplicates, in my opinion. But this one definitely removes more than is needed. So yeah, we have some other options to look at: spelling, stop words, word type, and or maybe as for now, we can use some LLM to do the analysis for us. But yeah, the data cleaning is again some judgment calls. So yeah, we're just using this as one example. I think we're gonna proceed with this first unique ingredients. Great. Now let's do some explore of the data. So first of all, cuisines. How many cuisines are there? All right. That's our location data, and we want the length of how many countries are there. So there are 20, and how many recipes belongs to each cuisine. So it's just sorting like for all the cuisines for which keys are it belongs to. So we have about 8,000 of Italian cuisines and so on and so forth. And we can make a beautiful pie chart to visualize how many are there. So yeah, Brazil has the least cuisines in our data set. All right, where are they from? So yeah, here we're using this geo-region value plot to plot where the cuisines are from. So yeah, here Italian, it has more, like over 7,000. So the color is red, and yeah, and here Jamaica, Florida. Even though it doesn't look like it's colored, but it's colored like here, pale yellow. So but yeah, there are many different properties that you can manipulate to change the appearance of how they look like, and change how the whole map should look like. All right, now let's see how many recipes are there. So yeah, the duplicates are removed, and then this is just a step of validating our data set to see how our data got cleaned, and they should be the same. Great. So we now have about 40,000. So what is the average number of ingredients of recipe? So here we're just looking into the recipe length of each recipe, and we can do some calculations because now we have numbers. The mean is about 10, 11 ingredients. Median is 10. And then we can also do some standard statistical measurement, mean, median, standard deviation, something like that. All right, what are the longest and shortest recipe? So yeah, here we're just finding the length of recipe by this function minimum by to get the shortest recipe, sushi rice. just have one ingredient, I would assume that is rice. So yeah, and we can also find the longest recipe by this function maximal by. So yeah, let's see. For yeah, this one has 30 ingredients. This also have 30, and also another 30. Yeah. Remember that we did the cleanup to remove all the outliers that is longer than 30. So yeah, this also align with our cleanup. Great. How many ingredients are there in each recipe? Let's give it a look. So yeah, for the raw ingredients, we have done the first step analysis to just get an idea of how many ingredients are in the recipe, and remember that there were something out here more than 30, some are like 40, 50, but just one or two. But as for now, this has been cleaned, so everybody everyone every recipe now has less than 30 ingredients, and most of them are in the 10, 11, 9, 10, 11 here. Great. Yeah, we have some optional section here, which I'm just not gonna talk about because we have a lot to cover today. So yeah, I've put the graphs, like how the outcome should be like here, and yeah, you can take a look if you have time later. All right. So next, what does a typical recipe look like? Again, I will use a interpreter to do some analysis, and yeah, using interpreter will take some resources and time, so we've pre-done that, and I'm just importing my stored file, and let's see how it looks like. Great. So yeah, what is this? It's a spam, and gramolata, not sure what that is, and carbonated beverages, soda. So yeah, that's our food entity. And again, these are entities, though, so they contain a lot of information, and we can see what are those properties are in the food example. Let's see. Mm, random sample. Let's have 5 maybe. So yeah, fiber label, protein, calorie. So yeah, you can query for any of these from our entity. So now we're just replacing each ingredient with a unique counterpart. So yeah, we're just replacing the unique ingredients and with these food entities, I believe. So yeah, that also takes some time. So here we are, just importing the files. And then again, we're removing the duplicates. All right, get a random recipe and then make the recipe into this entity group so that the entity calculation will apply to all of them. So now we just get a random recipe, and it is of jam, zucchini, salt, onion, yeah, things like that. So now let's see what's the distribution of calories, protein. Yeah, I believe. Oh, all right. This one doesn't have any fat, but have a lot of carbs and some reasonable protein and some reasonable calories. Sounds like a very healthy food. All right. Now we can look into the nutrition label, just as what we see when we're buying food from grocery stores that it contains how much sugar, the what percentage of daily input, something like that. Yeah, because it's query for entity value, it might take a second. All right. All right, let's try this again. Maybe it's just hitting some food that um, doesn't have that nutrition information. But yeah, let's do it again. All right, for this one contains pretty much. All right, now, yeah, 24% of total fat. Yeah, which is like here. So yeah, that is some good information. All right, now let's look at ingredients. So, uh, unique ingredients 1600, and let's just create another list of ingredients. All right, so it's just taking the recipe data and then taking all the ingredients. So that's a lot, and I think we will just be matching it later. What are the least and most common ingredients? So yeah, unique ingredients count. Let's see. Let's see it in a data set. So yeah, this is just the visual present representation of this part of code. So yeah, uh, for all the recipes, there are 18,000 that contains salt, and the second most popular one is olive oil, water, onions, which it's reasonable. And we can generate a word cloud to show like which one is more popular. Yeah, apparently the popular ones are bigger. All right, now let's that was just some basic understanding of the data set. Now let's just do some deeper analysis. Which ingredients are often found together? So first of all, we're going to find like we're just pairing all the unique ingredients, and then to see, so this pair, back ribs and crumbles, when they pair up together, they appears in 16 recipes. So yeah, these are all the pairs. And now let's have a look at the histogram. So yeah, let's see. Counts of ingredient pairs in the recipe list. Oh, I would say this means that just one, so one pair, and it only appears once in each of the recipes. There are 7,000 pairs uh that only appears once in the recipe. That's how I understand this. Great. And we can do some reverse sort. So yeah, reverse sort that to find which one is very popular. The pepper and salt combination have about 6,000 appearances, and yeah, so on and so forth. And here we also have like a matrix form to represent the data. And how do the regular recipe compare to the unique ingredient recipes? So yeah, here's a histogram of yeah, looks about the same. Recipe string length mm, more towards here, and yeah, here looks about the same. All right, what do the unique ingredient features look like in feature space? So now we're using this feature space plot to cluster ingredients. So um, that when they have when the machine will decide if they have similar features, they'll put them into a closer distance. And as for this one, the criteria we're using is to use the string length as the feature. So yeah, for this cluster, they should have the same string length. I'm not sure, about 20, 25. And for here, these are the very short ones. And here are like 5 or 6. So now let's just use the list polar plot. Um, so same information, like in the middle, it's the string length to be 3 maybe, and then 4, and then 5, and then yeah, just showing the analysis of how long an ingredient has. All right. What do the recipe features looks in feature space? All right, now we are using this dimension reduce function. I believe that this function use some machine learning to um, yeah, reduce the dimension of the data into just two-dimensional. So yeah, this one. So Greek recipes have these ingredients, and then yeah, each ingredient is just put into like this two-part coordinates. And let's plot that. All right. So yeah, as we can see, this part, this orange part, I'm not quite sure if it's India or Thailand. It looks about the same color to me. But um, by the machine decided that they should be clustered together because they're similar, which makes sense. So they are put all together here. And then for this green part, maybe Italy. So yeah. And what are we looking here? It's how like taking this one out and to see for each different cuisine, how are they clustered. So yeah, this Florida one, Italian one, they are more clustered than some of the other. All right, here, how many recipes are there per capita? So this is just using the recipe to divide it by country. So country population, country or region population. So yeah, like India and China have smaller ones, which is probably because we don't have a lot of recipes here in our data set, but they do have a lot of population. All right. Which cuisines tend to have the most calorific recipe? So this will just take us looking into the calorie counts for all the recipes, and then yeah, most of them are less than one. Oh, calorie counts. So yeah, there are about 120 that are lower calorie. So here, get the total number of calories in each recipe. This might take a second. All right, let's see what they look like. Great. So yeah, it's just this is the first recipe. All the ingredients adding up together. Second one, so forth. And then now we can do a distribution chart to show to find which cuisine has the more calories recipes in them. And it seems like Morocco cuisines that have more calories in them. All right, now, yeah, that's some understanding from the data science point of view. Now we will look into the machine learning part of this. And remembering our question at the beginning is that given all these ingredients, which this recipe is from which country? Is what cuisine? So yeah, our building function classify can just do the work. So yeah, first of all, we're just gonna set up the data. Again, we are gonna remove the entity part of what we originally have. We have the cleaned version of data. But as for now, entity, all those nice features, nice properties, calories, it doesn't matter. So we're just gonna replace them with this plain string, just telling the data set which country they're from. And yeah, just putting them back, saying like the cuisine is Greek and it has these ingredients. And then we will restructure the data into a list of example and goes to class. So now we just change the data structure into how classify would need to do its work, to do the machine learning. So the structure is the all the ingredients, and then for these ingredients, then it is a Greek recipe. So yeah, for typical machine learning, we would like to separate the data into a training set and a testing set, and typically it's 80-20. So now we have our training data for this much of data points, and then our testing for this much. And now we can create and train a model. It is just as simple as that, just one line of code. And then we have our classifier. So yeah, here we can get some more information of this classify function. And of course, we can query for more. Using this classifier measurement, and this classifier measurement object can provide us so how this model is behaving over this testing data. Let's see. All right, now let's look at it. So the classifier method was Markov. It's the same as we can see the information here, and the accuracy is 75%, pretty decent. And yeah, there are just some other informations. And below here, this is a confusion matrix. And on the diagonal here, they are the accurate prediction. So yeah, there are 1,200, 1,300-ish Italian recipes that got identified as Italian, but there are also 115 Italian recipe that got identified as French, which is reasonable because they're closer. So yeah, we can just query for some other properties, and accuracy 75%, confusion matrix. It's just pulling out this if you want to use it. And here are the position of which are the better predicted category. Mexican, Indian are on the better part, and then the not so great ones are Irish, Russian, and British. And now we can look into some worst classified examples, and yeah, so uh yeah, ice cream, brown sugar, buttermilk, yeah, this looks like some dessert recipe, and it is from Louisiana, but it might come from anywhere, to be honest, to look into this recipe. That's why it is worse classified for a reason. All right, now let's look at how they compares. So original label Louisiana, and it is predicted as Florida. So yeah, just as I said, the dessert one that may be anything, and Filipino that got predicted as Chinese, which is also reasonable because they're closer, like shiitake, yeah, sesame seed, yeah, those Asian ingredients. All right, and let's get to see the top confusions. So French are confused with Italian cuisines, Florida with Louisiana, British with Florida, Greek with Italian. So, oh, 1 second. All right, now let's plot a graph for that to see which one is connected to the other. Yeah, here like Europe, Central Europe, and Mexican and Spanish, they have influence over each other, and Florida, Mexican, South America, yeah. But I'm not sure why British is connected to Florida, and Moroccan and Indian, maybe they have some similar spices. Vietnamese and Thai, reasonable, closer. So yeah, now we can use geograph plot to see which one are connected to which. So yeah, these are closer geographically, and here Europe, and here like South America, Central America. All right, now that's just our very basic machine learning module, and now we can use some different method to reduce bias. So first of all, we want to balance the data. So as we remember that for our data set, there are 7,000 something Italian recipes, but only like a couple of hundred, 400, 500 for Brazilian cuisines. So we want to balance that out because let's say the machine will think, oh, for some recipes, it is just higher chance for them to be Italian because we have more Italian recipes. That is apparently not our case that we want here. So we want to do some of the data balancing first. So yeah, here, as you can see, I put in some comments just for some better understanding of what is this code doing and what we're looking at. So yeah, it's just some good coding practice. So as for now, we're taking from the training set like the minimum count of one of the cuisine. I'm not sure which one. Let's just say Brazilian. So in this training data, we have 368 Brazilian cuisines, and we just want to match that for all the other cuisines so that everybody has the same chance to be in the same um, probability to be like which country that is. And then when we have this new data set, we're just going to train a different classifier as this one is using. Yep. And we're just doing the measure the model against the testing data. Again, same thing. It's not increasing the accuracy. The reason why is probably because we reduced our dataset a lot. I remember our training examples are 30,000 something, but as for now, it was downgraded to like 7,000 something. So I would assume that's the reason why the accuracy is not increasing. But yeah, same thing. And now we can compare the current one with the original model. So yeah, it's still doing pretty well for the Italian one, I guess. All right. Another solution is to tell the model, well, instead of manipulating the data set we're using, another way is just telling the model use this class prior function. So it's basically telling the model that the the probability of this cuisine, this recipe, it's exactly the same for each country. So we have 20 different cuisines. So um, for one certain recipe, it will just be 1/20 probability that it is Italian. Also the same 1/20, it could be Chinese. So this is just removing the machine guessing, oh, we have a lot of Italian, so this might be Italian. So yeah, we're removing that. And again, we are measuring the model against the testing data. So yeah, it has increased a little bit. All right. Features. And what we're doing here is just we're padding the training data. So um, what it's doing here, it's we are producing some new recipes. Well, they do have the same ingredients, but just the order of the ingredients are scrambled, so they're considered new recipes because we wanna reduce the effect of how different ingredients, the ordering of different ingredients might affect the machine um, to classify each of the recipe. So yeah, we're doing that, and then the shorter recipes, let's just say they only have 3 ingredients, and then yeah, scrambling them is not as will not produce as much as scrambling like 9 or 10 ingredients. So yeah, basically we just have this padded training data, which contains more data points for the machine to process. And now what we're doing is to do the training again with the padded data to see how it works. So yeah, see, as for now, our training examples uh, got over 72,000, which is double the size of what we had before. And yeah, is it doing better? I'm not sure. But yeah, this is just an idea on how you can manipulate your data to produce some different aspects from for machine learning. And here is also another way to manipulate the input type. And remember, we've always been using a list of ingredients and then telling it, oh, your Italian recipe. But here we want to put the whole list of ingredients into one string so that if we can see classify can use some different processing material to understand it and maybe using some different algorithm to process the data. We'll see. Let's train another model. And then again, we're using this classifier measurement to see what's going on. All right. We can also build a custom feature extraction function. So here we're using this term frequency inverse document frequency method. Yeah, if you're interested that you can read about it, but as far as I understand, it is doing some strain analysis on the frequency of words and assign weight to different words. And if they have duplicates, like they appear more, some of them appears more in all over the document, then it is weights more. And then there are some that are unique that does not appear in the full text. They are weighing more. So yeah, we're just training this feature extractor function using this string training data and then this method. And now we are training another new model and specifying that we're using this feature extractor. All right, now as we can see, yeah, we have our learning curve. Accuracy is going up. Yeah, this will take a second. So yeah, for classify, we can limit the time of how classify use, and we can also find a balanced way of time and performance. So yeah, it's just different goals that we can use. We can set the time goal to maybe 1 minute, and for for some modules, for some tasks, you will probably say, time is not an issue. I want it to be more accurate. So yeah, there are building functions, building properties for classify to fine tuning all of that part. Yeah, let's just give it a second. I can pull out the documentation center to show you how classify works. 1 second. All right, so this is our documentation center, which contains a lot of useful examples of how you can use this function. So yeah, here, this is how the data sets are taken in. And here are some those fine tuning properties that you can use. And here are some built-in classifiers. Like you can see which country flag this is. And yeah, the following options, which yeah, we've seen this too. And method, yeah, we can show that later. And performance goal, this is what I was talking about. You can limit the time of it, and you can set. All right, I guess this is not looking great. Let me restart it. Oh, all right. All right, so we have our trained um, trained classifier using this feature extractor. Now let's see. Yeah, same thing. Classifier measurements, and yeah, same matrix plot. So yeah, the classify options, just as I showed before, um, just now in the documentation center, we can. All right, let me do some. All right. So yeah, here we're just training this classifier, just specifically asking for using this gradient boosted trees. it will still show the properties and the confusion matrix data. So if it's taking longer than it should be, then I'll just abort it as for now. But yeah, it will just basically showing this same thing, telling you the information about this classifier. All right, validation. So if we're not specifying our validation data, then the machine learning method, the model will just use its um, own splitting in the training data, but we can split the data first into training, testing, and validation sets. It's 70, 15, 15. And now we can create and train a new model with this validation set to be our validating data. So this helps classify to train itself better with some unseen validation data. All right. Um, Here again, same information. All right. So for all of the models we talked about, we are now just going to combining everything together to work on some of the data it has never seen before. So first of all, we're just gonna import our JSON file from our lovely website, and then clean up the data. So it's just ingredients. And now we have our final model. First of all, splitting the data into training and validating. And this time, because of the testing data, it's a completely brand new data set that it has never seen. So we can just do this 80-20 for our training and validating. And here, again, we're doing some padding, produce 9 different scrambled version of each recipe. So yeah, just increase the size of the original data. And now we are training our classify function, our machine learning model, with this padded data, and yeah, and assigning the weight of each cuisine. It's just their the same probability, and giving it the validation set. So now we can apply the model to the testing data. All right. Now let's just count the this one, it's not only doing the measurement, it is matching like which recipe is matching with which cuisine. So like this unseen recipe, we classify it, the model classify it as Italian. Yeah, something like that. So now let's look at how it turned out to be. So as of this unseen recipe, there are 1,400 of Mexican food. Yeah, 1,400 of Italian. So now we're just comparing it with what our training data was. Yeah. So yeah, here is our last part of today. It's after all the data processing, we want to do some visualization. We want to present it in a nice formatted way to different audience that might have technical background, so that we can move into the more data heavy way, or the non-technical background audience. Then we can just make it less technical but more understandable. So yeah, here we're just basically recreating what we have seen today for the beautiful graphs. So first of all is the pie chart. For here, um, we're just setting up a function of how to make a pie chart. You can modify what color they use, the size, those cosmetic things. And then here we can bring in the data just as using this function, just one function and the data. And now we have the pie chart. Same thing for doing this distribution chart and just pulling the data. So yeah, here it's still the American food that are more has more calories and histogram. Same thing. We're looking at the recipe length. So it's like 9 or 10 ingredients in one recipe. And here, list plot. Yeah, we're looking at the feature extraction plot. So yeah, here was the all right, now this time I guess it's Chinese food, like here. So yeah, how they are clustered, and again a word cloud. So yeah, basically all the setup is just you write the function for visualization, and then you pull in the data. And list plot. All right, now we have all the plots set up done. So yeah, just remember we've done all this making all these functions. And now we just want to put it in a nice dashboard layout. So yeah, here are just some setup for the function. All right. Yeah, just to put it in a nice grid way. Yeah, let's give it a second. All right. Oh, this is huge. All right, here it's what we're gonna present in the end. Now we have 20 cuisines, like each from these different countries, and the calorie analysis, recipe analysis, and ingredient analysis. So yeah, in a very presentable dashboard way. So yeah, I guess that's all for us today. And yeah, in the end, I'll do a summary. So import the data, cleaning, formatting, and doing some exploration, basic exploration, and some deeper analysis and machine learning, and then in the end, put everything all together. And it is a data science pipeline. So if we have some other new recipe data that comes in, we can just easily pull those into this framework, and we don't have to do all the setup, cleanup again. So yeah, and yeah, we have some other resources to help you have a better understanding of how data science, machine learning is working in Wolfram language. We have some WolframU courses, and here are the free repositories, function repository, neural net repository, demonstration, have a lot of examples of like different manipulate models from different areas, like math, physics, and yeah, here is our documentation for what's new in Wolfram language. And we can also look at the blog and community to look at other people's project. So Yeah, here are just some useful information for data cleaning and this function, that function. So